Vincent, can you put on your video, please? Michael and Mr. Fabrizio, can you please put on your videos as well? Put on your video, please. Thank you. Okay, we shall begin. A very good afternoon, ladies and gentlemen, and welcome to today's MPMA webinar entitled Solvent Recycling Technology. The webinar is fully sponsored by Recommend. To begin with, let me read out the webinar etiquette for this afternoon session. We have muted and turned off video of all the participants to ensure no disruptions throughout the webinar. Participants may ask or post questions related to the presentations in the chat box during the webinar. The speakers will only answer questions that are clearly written and based on the presentations. Kindly refrain from marketing your goods or services in the chat box. The chat box is only for queries related to the presentations. The organizer reserves the right to remove participants who run afoul of the webinar etiquette. Ladies and gentlemen, this is the program for today. We'll be seeing two presentations this afternoon, one from Mr. Michael and one from Mr. Fabrizio. And it now gives me great pleasure to introduce our moderator who will handle the webinar this afternoon. Our moderator is the Executive Director of TS Plastics, Sendirian Berhad, and he spearheads business development initiatives aligned with TS Plastics strategy and core competencies. He also directs technological improvements, reducing waste and business bottlenecks. Our moderator has over 23 years of experience in the flexible packaging sector, and he has a bachelor's degree in mechanical engineering from National Chin Yi University Technology. Ladies and gentlemen, I now pass the webinar to Mr. Vincent O. Vincent?
Thank you, Francis. Ladies and gentlemen, good afternoon. Before we begin, I would like to say a few words. Today's webinar is about solvent recycling technology. If you run a business that uses solvent in your day-to-day operation, the only logical choice for dealing with your waste solvent is recycling them with an on-site solvent recycler. Amongst others, the technology benefits include: number one, recycled solvent is much less expensive than virgin solvent. Number two, with today's technological advance, there is literally no noticeable difference in quality between a product that comes from virgin resources and one that has been recycled with an on-site solvent recycler. Number three, you cut out shipping costs from the equation. Number four, keeping the solvent recycler process in-house and on your job site greatly reduce one's reliance on interrupted supply chains. Last, companies are ultimately responsible for any hazardous waste you produce from the time they are generated to the time they are finally disposed of. This technology helps with the graded to grave liability. With this in mind, I now introduce our first speaker for today, Mr. Michael for DW Richmond. He graduated as a mechanical engineer in year 1992 and joined DW Richmond the same year in August. Until 2004, he has been in the sales team of DW Richmond, responsible for North America, some industry in Germany, Middle East, and Africa. Since 2005, he is the member of the management team and still active in the sales with direct contact to our customer worldwide. So we welcome Mr. Michael.
Yeah. Thank you very much, Vincent, for introducing me, and thank you to MPMA for the invitation to be part of that event today as a speaker in name of D.W. Rensman. Now I would like to share my screen to start my presentation. Sorry, I can't. Okay, now, okay. For any reason, I can't get to this. Okay. For any reason, I can't switch that off. Okay, you see the, okay, it doesn't matter. You see the presentation from my speaker's point of view. I don't know why I can't switch that now to the standard. Okay, okay, good. We have to continue like this. Okay, what we are talking to today, it's about sustainability. We are talking about saving rare resources. We are talking about improving environmental footprint. And of course, we are talking about saving money. And my presentation is about recovery of liquid solvent and flexible packaging printing. Then we are talking about liquid solvents. Then we have to think about where this solvent appears in printing and flexible packaging. I don't know why this doesn't work.
Michael, you can go to the tab at the top, the second tab at the top. You just do a swap. The other one.
Okay.
The second one, yeah.
Okay, I could get rid of it. Okay, this line was somewhere.
Yeah, sentence.
Okay, okay, thank you for your help. Okay, good, thank you. Sorry, okay, we first have to think about where do all the solvent appear in flexible packaging printing. Flexible packaging printing, actually we have two different ways to print, either gravure printing and the other one is flexo printing. In flexo printing, we have a first step to produce the flexo plates. When producing the flexo plates, we use washout solvent, so-called washout solvent. There are actually two different types of solvent available in the market. Either is a mix of perchloroethylene plus butanol. This is something actually it's used in the past. It's getting very rare. Meanwhile, this solvent mix is has a boiling range of about 120 degrees Celsius at atmosphere. Meanwhile, other special products are coming up, for example, from DuPont. They are mainly based on hydrocarbons and benzyl alcohols, and they are boiling in a much higher range, 185 up to 220 degrees Celsius. Yeah, so when producing such flexo plates, at the end you have used solvent which you have to handle in any way. Yeah, and then the next solvent. The next solvent source is number 2. It's about cleaning at the print shop. When you have finished a printing job, you have to clean the parts of a printing machine which has been in touch or has been in contact with the printing ink. There are 3 different ways to do the cleaning procedure. One is manually with clothes and solvent in barrels. It's not the most modern way. of course, but sometimes it's still common or even necessary. But at the end, you have used solvent, which is contaminated with some parts of inks and some other things. The more professional way to do the cleaning is disassembling the printing press parts from the printing press and put them in a professional explosion-proof washing machine to clean these parts, like in a huge dishwasher, actually, by a solvent at the end. Again, you have dirty solvent you have to handle with. And finally, the modern printing presses have inline cleaning systems integrated at the machine. So you don't need to disassemble the printing press parts. Then using this integrated cleaning system, you are flushing all these parts before you start the next printing job. Again, the same solvent you have to handle at the end. So what are these? What is the composition of these types of solvent? They are mainly based on ethyl acetate, some alcohols, and the boiling range is about 80 degrees Celsius, a little less sometimes, but about 80 degrees Celsius at atmosphere. Source number 3. This is waste inks. Sounds a little bit strange, but sometimes printing inks are left, and there's no opportunity to use these inks anymore. So of course you can also give it away, but it makes sense also to recover these waste inks to get out at least the main part of the solvent, which is exactly the same what I mentioned at source number 2. It's again a mix of ethyl acetate, some alcohols, and characteristics, of course, are also the same. So how to handle all these solvents? Option number 1 actually is no option. I'm sure you agree to me. Put in drain. Of course, no option due to environmental impact. Option number 2, return to suppliers sourcing virgin solvents. Actually also no option due to extraordinary high cost, because that would mean you just collect all the dirty solvent, give it away, just buy new virgin solvent. Option number 3 is a little bit better already. It's treatment by external reclaiming company. That means you also collect all these solvents. You organize the transportation from your printing site to this reclaiming company. They treat the solvent and you get recycled solvent back. It's better than the other 2 options, but it's still not the best, because first, the return rate of such a treatment at a reclaiming company is about 65%. That means you need to compensate about 35% of your solvent losses by buying new virgin solvent. The second one is, again, you need to do a transportation. You transport your dirty solvent to that company, and you have another transportation of your solvent back to your printing site. For transportation, you also use some resources. And at the end, what you get back as a reclaimed solvent is not validated regarding content, because, of course, you mainly get back a mixture with solvents you have been at your site before you gave it away for treatment, but these companies can't separate the streams 100%. So what you get back is mainly the mixture you gave to them for recycling, but there will be also some other solvents, little part of solvents, which never have been at your site before. So coming to option number 4, which is the best, it's an in-house distillation. You keep your dirty solvent at your site. You operate the distillation system, which handles all your dirty solvent. The best actually is even to do a hard pipe connection from printing press, from washing machine, from some solvent containers to that distillation unit. At the end, we have recycled solvent you can directly reuse for washing and other applications again. Of course, then you have validated content of the recovered solvent because you just treat your own solvent in the cycle. You have a little loss because the most modern distillation units operate with a recovery rate of 98%. You have a little loss, you have to compensate, but much less as option number 3. It's the best possible economical footprint, and ROI is less than 2 years at a solvent consumption of 30 tons per year or even more. So how does a professional distillation system looks like in principle? Actually, it's like a distillation vessel, double-walled heating bottom, or even at side. There are different designs available on the market. The heating of these systems are mainly done by electricity. Sometimes we use also steam or thermal oil. While distillation, we heat up the dirty solvent and we need to condense to get the distillate back. So the condenser has to be cooled by chilled water. The units are either run by in batch-wise operation or semi-continuous operation. Batch-wise means you just fill up a unit and you distill what is in that distillation vessel. Semi-continuous means you start the distillation process and all a few minutes, a small portion of dirty solvent will be added till a specific preset time is finished or a specific preset amount of dirty solvent has been treated. I will come to back later. The essential part or component of a professional distillation unit is a vacuum system. So we distill these solvents under vacuum to reduce the boiling temperature of the solvents. That's the reason I mentioned the boiling temperatures in the beginning in atmosphere. So, for example, when you see this diagram here, you see ethanol, which is a quite common component of a solvent mix. Under atmospheric pressure, you have a boiling little less than 80 degrees Celsius. When you reduce the pressure down, you easily drop down the boiling temperature at about 33 or 35 degrees Celsius. So this improves already the efficiency of a distillation process, but it also has a safety impact. When we speak about distilling solvents in the printing industry, especially in packaging printing, and these solvents contain inks. The most of these inks are solvent-based. And a lot of these solvents, of these inks are nitrocellulose-based. Nitrocellulose is a temperature-sensitive component. So we have to be careful about this. Nitrocellulose could create an exothermic reaction when it's in contact with temperature higher than 100 degrees Celsius. You see, now you understand the safety impact of vacuum system. Under atmospheric pressure, under pressure, we reduce the boiling temperature. Also, the heating temperatures could be much less. So we have a safe gap to the 100 degrees Celsius. So it's written again. In addition to vacuum, we also recommend to put an NC safety package, nitrocellulose safety package on the distillation system. Of course, while the distillation unit needs a temperature control system, but the nitrocellulose safety package has an additional redundant temperature monitoring system, which constantly monitors the temperature inside the distillation unit, especially where where at the area we're close to the heating surfaces to avoid that we exceed 100 degrees Celsius. In case, for any reason, the temperature exceeds with a limit of 100 degrees Celsius, this NC safety package switches off a distillation unit, means switching off the heating. When an exothermic reaction already started because of nitrocellulose and the temperature rises even more, this NC safety package starts something like a water flooding of the inside of a distillation vessel, because just water can stop a nitrocellulose reaction. So, but this is all under control. This is just a safety package we recommend for a distillation unit in the printing industry. So how is a setup of a professional distillation unit? You remember I told you it's a cylindrical distillation vessel with a heating bottom and a scrapper system. I will start later just so we see the movement. Scrapper system is an important item as well, because to avoid any partial overheatings while distillation process, or to avoid any incrustations at the heating surfaces, we recommend distillation units with scrapper system, which continuously moves the product to be treated and avoids any incrustations at the heating surfaces. Next to the distillation unit, we have a container with used solvent, and we fill up that the distillation unit by under pressure. By under pressure, we suck in the dirty solvent to fill up until here. You see, it's not filled up to maximum. I will also tell later why. Okay, then we heat up the complete system, and while boiling, the vapors are rising up to the condenser. And the distillate drains out as liquid inside the distillate container. So this is the end of the distillation process after we have switched off the refilling mode. This is what is left inside the distillation system. I will start again, so it's very short. It's quite impressive, I think. That's what is left, and then the scrapper system turns the other way around to drain the residue. Scrapper system pushes the residue down through the gate valve inside the residue container. Okay, now we'll give you another animated, or it's actually interactive presentation of the unit. So I have to switch off my presentation to share another file. Okay. You maybe remember the schematic animation of the distillation unit. Now this is an presentation based on the real 3D drawings of such a distillation unit. So it's very realistic. So I would like to give you a short tour around the system. I come also a little bit closer for you. You see, it's just this cylindrical distillation vessel based on this frame. Turn around a little bit to also see from the rear. You see the condenser. And what is interesting at this design is the distillation unit itself, including the condenser, is mounted at this blue device. I also get a little bit closer to make it more obvious for everybody. and it's hinged in the back, but also placed on load cells here, and also at the other side. I go back to the left side. You see also here it's the other one. That means that distillation unit controls the filling amount of solvent inside the distillation vessel, not by a filling level control, which is integrated inside, but the unit controls the weight itself. The PLC control is preset to the net weight of the distillation unit itself, but it controls the cross weight, so it knows exactly how much product is inside the distillation unit counted in kilograms. Now let's see. I would like to take a view to the inside for you. It's a little bit much, so let's open like this, a little bit closer. You see the scrapper system inside, and I also can start a very short video to make it even more obvious. Okay, this unit is closed for the residue area. So you put a residue container underneath while distillation process, the scrapper system is rotating and maintaining the heating surface. You see it's getting dark. That means we are collecting more and more sludge. At the end, the scrapper system turns the other way around to drop down the sludge into the residue container underneath. I will give you also another view to understand even better. So I will close the unit again. Okay, I give you another view, which is even makes it even more obvious. So let's go from the side. This distillation system has an integrated steam generator, which is driven by electricity. You see this yellow part in the back. So it creates its own heating steam. The steam will be guided to the heating bottom. So we just heat up from the bottom. A little bit closer for you. That sounds a little bit like a disadvantage in the beginning, that we just heat up from the bottom, but because there are sometimes also some distillation systems available on the market with heating also not just from bottom, but also from side walls. Actually, we do both, but this very modern distillation unit just heats from the bottom. Why is that an advantage? When we speak about distilling solvents from a printing job, we have the different kinds of solvents we were talking about earlier. But sometimes, because maybe also some water-based inks are printed, we have some components of water in the dirty solvent. And distilling these solvents with a little portion of water under vacuum, in some moments, not by the complete process, but sometimes, especially in the beginning, is creating some foam. Foam is actually not something so bad, but this foam mustn't escape from a distillation vessel to the condenser, because this foam could carry some pigments, and at the end our distillate would be contaminated. So what we would like to do is to control the foam and to keep it inside the distillation vessel. That means we fill up the distillation vessel maybe just for 20% or even less, and we keep the rest of the filling capacity of the vessel free for foaming. That means to control that and also to set up a distillation unit always individually, it means we need to be flexible about filling amount or filling amount of product inside the distillation vessel. That's possible when we have a distillation unit with load cell design, because then at the PSC control, we can set up, we just fill maybe 50 or 100 kilograms of dirty solvent, which is somewhere around here. And then we have a complete distillation vessel free for foaming. If we face even more foam, we just reduce the filling capacity. But you realize that there is no disadvantage, because the heating surface is always 100% in contact with product, because there's no influence about filling height or filling amount. That's the reason we prefer to heat just from bottom. Okay, I can start this process again for you, just to give also a view from the other side. Okay, again, we move the residue drum underneath. Okay, we fill up. You see, it's not filled up that high. By the entire distillation process, the scraper system is rotating and maintaining the heating surfaces. At the end, we turn the other way around to move the residue to center. And in the center, we have a gate valve, which is opened to drain or drop down the sludge to the drum underneath. Okay, good. I will close the unit again. There's another item or part of a distillation unit I would like to show you, because I've addressed it very intentionally and very detailed in my first part of presentation. It's about vacuum. This is a vacuum system. Actually, the vacuum system is just a small cylindrical container filled up with clean solvent, the same solvent mix we are treating, and a centrifugal pump. This centrifugal pump just circulates clean solvent through this pipe up here, through this pipe and back to the container. That doesn't sound so spectacular, but it show you why is it so important. Go a little bit closer to make it even more obvious. Okay, here we are. You see this very small pipe. This is a Venturi nozzle pipe. That means the solvent stream goes through this pipe, through this Venturi nozzle pipe and back to the container. And Venturi nozzle pipe has a wide opening and a very narrow opening. Close to the very narrow opening, the flow speed is very high, but there's under pressure. We use that under pressure as a bypass to connect to the condenser from there to the distillation unit. So this creates our vacuum. And this is the vacuum unit design, which is certified according to the European ARTICS certification and requirements, because there we don't move anything mechanically in a mix of liquid solvent and solvent atmosphere. There are other designs of vacuum available on the market based on liquid ring pump, but a liquid ring pump operates something, moves something mechanically inside the pump in a mix of liquid solvent and solvent atmosphere. So there's a risk of explosion, especially as solvents with flash point less than 55 degrees Celsius. Okay, I would like to go back to my first presentation. Okay, so this is what I wanted to show you about solvent distillation, liquid solvent distillation, and what were we are talking about. Let's start, go back to the beginning. We were talking about sustainability. Saving rare resources means saving solvent, means treating or recycling the solvent as much as possible. Again, recovery rate 95 up to 98%. We were talking about improving environmental footprint, means distilling in-house, no need for transportation, no need to invest in further resources, and of course, saving money. Remember, ROI less than 2 years. Now I'm open for a question, but first you wait for the second presentation. Thank you very much.
Thank you, Michael. Vincent. Okay, Vincent.
Okay, so now we are welcome our second speaker, Mr. Fabri. So he's joined OMGC Charity SPA as a field engineer in 1994 for 5 years, and later promote and expand his roles in the same company as area sales manager for 13 years, taking care of different sales regions worldwide. In 2014, he took up the management roles as Vice President of Sales for 9 years for Charity Packaging Equipment SPA. In 2021, he moved on his career as a Vice President of Sales for DEC Inventi for worldwide sales. So now we welcome Mr. Fabri.
Yeah, thank you very much. Thank you to MPMA and to Rickerman for inviting us to this very interesting webinar. And so let's start. I will share my screen. Okay. Okay, while Michael was talking about recovering solvents liquid to liquid, I will present you our slides from DEC Impianti, and we are taking care about recovering solvents from the vapor, from the fumes exhausted from your printing machines. DEC is an Italian company, is a family company owned, and we recently celebrate our 75th anniversary last year. So it's a long story of innovation, of technology. We are present all over the world in different countries. Specifically talking about Southeast Asia, we are a partner of Rickerman. So Rickerman is our agent for the entire Southeast Asia. And DEC is a workforce of around 250 people, working from engineering, R&D, and of course in our workshop. So let's start immediately to talk about our target. When we talk about sustainability, we mainly face three items, three main issues that our customers also are facing every day. So taking care about the VOC, the emissions, CO2 and greenhouse gases, and to take care, to try to minimize the excessive use of Earth's natural resources. So how we face and how we want to solve these three main issues. let's say that we typically look to switch from the old concept with the assumption to use one time our solvents and lose the solvents like in the emission to the atmosphere, or even worse, to burn with the oxidizers, RTO. We want to move to a circular economy. And DEC in this field is a worldwide leader in the solvent recovery systems for flexible packaging. We have installation worldwide in every country, and we are really the world leader when we are talking about a solvent recovery system from the vapors exhausted from your printing and converting lines. As a matter of fact, we are the supplier for the main multinational accounts. You see the biggest name here on this slide, but we have many other customers from medium to even small size. You see here the only few examples and for the recent installation that we sold in the last years, but there are many others. We have hundreds of customers all over the world. So let's start to talk about when I have to face the problem that I mentioned before, how I can treat the VOC that are generated by our converting lines. There are mainly only two alternatives in this market. So one is to use the RTO, so to burn the exhausted solvents from our converting lines. The other one is the solvent recovery units, which is the core business for DEC. Again, this slide shows the two alternatives. On one side, the RTO are just contributing even more to create emissions, because when we burn our solvents, we increase again the emission of CO2 and other greenhouse gases, while the solvent recovery is aiming to protect the environment, to recover the solvent and to avoid emissions to the atmosphere. This slide is a schematic, shows the open loop of a company using RTO. So starting from the left corner, you see that a company using RTO, they still need to buy inks, adhesives, and then the solvents for the dilution of these inks and adhesives. And using those raw materials on the rotogravure, flexo, coating, lacquering, lamination lines. So in general, our converting lines, they exhaust and collect the fumes. They send those exhausted fumes to the RTO, which is burning. So not sending them to the atmosphere, but it's generating CO2, CO, and other greenhouse gases. And on top of that, we will see it's consuming a lot of gas or other natural resources to burn our solvent. On the other way, with the solvent recovery, we can say that we are closing the loop. Why? First of all, you see immediately on the left corner, we don't need to, typically, we don't need to buy anymore our solvents to dilute our inks and adhesive. Why? Because from the converting line, again, we exhaust the fumes containing solvents. We send these air with the solvents to the solvent recovery unit. We recover, we condensate and we recover, we will see more details later, these solvents in liquid solvents that we can reuse for infinite times as a dilutant for our inks or adhesives. So this is really a closed loop system, which it's not giving all the disadvantages given by the RTO. I don't want to lose too much time because there are much more interesting slides later on, but the RTO concept is just the only advantage that sometimes could have is that the investment cost for an RTO is lower than a solvent recovery system, but on the other side you have a lot of disadvantages. The only reason to go today with the crazy price of the raw materials with an RTO is only when the mixture of solvents used on our converting line is not recoverable, which is very rare case. I mean, typically, even the mixture of the solvent used on our converting line is recoverable. We will see later how. Then I think everybody knows that there is the target to go totally green in 2050, even before in some region in 2030, and the countries where this target is very sensible, they are putting more and more CO2 tax. So you can imagine with an RTO, if I contribute even to generate CO2, for example, in China today, the regulations are against the use of RTO, and the customer, they have to find alternative solution to get rid of this CO2 generation. And so we are expecting in the coming years that what is the CO2 tax will increase more and more, especially in Europe, but not only. So it's possible that European countries will apply a CO2 tax on top of goods imported from countries where this green target is not followed. So it will become a global problem. Using RTO, there are calculations that we can go more deeply, but just to give you an idea, when I use the RTO, I generate a tremendous amount of CO2, because, for example, when I need to produce 1 kilogram of additional ethyl acetate, for example, to use for dilution instead of recovering it through the solvent recovery, I generate 2.3 kilograms of CO2 in the process of production. Another 2.3 kilograms of CO2 is generated during the oxidation of 1 kilogram of ethyl acetate. And then to run the RTO, I even need energy. So it could be electric energy, gas, thermal energy. So again, I generate a tremendous amount of CO2, which only contribute to the pollution for our environment. And this is just to show you for a medium-sized company, for example, converting using 1,800 tons per year of solvent which is quite common in a medium-sized converting company, I would need a very big amount of trees to offset the CO2 generated by an RTO. So it's really amazing how the RTO is really not a energy saver equipment, is not respecting the environment, and is not convenient at all. So when it's possible, we of course we highly recommend to go to another technology. So to switch from a short life cycle, so from a linear economy to a circular economy, the only way, in our opinion, is to go to a solvent recovery system. The solvent recovery system, apart of the fact that you recover for infinite times the solvent that you use for dilution of inks and adhesives, in general will contribute to reduce, for example, the solvent production, the transportation of the solvents, delivery of the solvent to your plant, and cancel the emission to the atmosphere. So all these factors are impacting on pocket and economy, on the money and on the environment. With our system, we really want to minimize and have an efficient use of the Earth's natural resources. So we are able, with our patented system, to reduce the consumption of electric energy, the water consumption, the thermal energy, and even to reduce the consumption of activated carbon, because in our system, the use of the activated carbon, which is our main raw component that we use to filter the air, is minimized. So we really optimize our system to have the less possible consumption of energy in general. So we started more than 30 years ago with the engineerized solvent recovery system, up to today, where we can see we developed the smart modular system, which are the latest, which are the state of the art in the solvent recovery system. I show you a short video. In this video, you will see the concept, how a solvent recovery process works. So you see, starting from a printing machine, this is a rotogravure printing machine. We have an optimization of the exhaust air with the solvents. So we exhaust through the main exhaust duct, which arrives to the solvent recovery, where we have the absorbers with the activated carbon. The air will go through the activated carbon, which will capture the molecular of the solvents. After that, we have to condensate the solvents, which was still in a gas form, and obtain we have a dehydration process when necessary. to remove the excess of water from the solvents. Through the distillation columns system, which could be from 1 to 3, 4 distillation columns according to your configuration. We can even separate the solvents individually when necessary. Okay. So in 2022, we developed the 4th generation of our smart modular systems, which is the state of the art of the solvent recovery. As I told you, the first smart modular system series was born in 1998 and the second one in 2008, while the third one was developed in 2018. So the main target are to improve the performances, so to minimize the consumption of energy, to have a fast delivery time and installation, and to lower the capex also for this kind of systems. Okay, this is showing the core of the solvent recovery system of today. So if you follow the yellow arrows, you see that the skid mounted system, which is a pre-assembled structure in our workshop, will receive the SLA air, so the air coming from the exhausted air coming from our converting line, and through a filtering room and a, let's say, temperature conditioning room, because typically we bring the temperature of the exhausted air to 35 degrees Celsius. We blow the air through the activated carbon, which are in the adsorbers on top of the skid. And if you following the blue arrows, you see that we exhaust through a stack to the atmosphere the clean air, because we already capture the solvents in the activated carbon inside the adsorbers. After this process, while this process is going on, we already do a pre-dehydratation system of our solvents. Then when the activated carbon are saturated, we go to a regeneration process consisting of blowing hot nitrogen to the activated carbon in one of the adsorbers, while the other adsorbers continue to work in absorption phase. We regenerate the activated carbon in one of the adsorbers, which means we are able to extract the solvents from the activated carbon, to condensate those solvents to obtain what we call the raw dehydrated solvents. Once we arrive to obtain the liquid solvents, again starting from the exhausted air coming from your converting line, once we get the liquid solvent, of course, according to the process that we need to do, we can go to the distillation or directly reuse the solvents in our production stream. The solvent recovery system, as we said before, use some energy to cool or to heat up during the process. This can be done with two different versions. So we have a full electric version using only electricity to heat up when we need to heat up, for example, the nitrogen during the regeneration. The system is using only electricity, nitrogen, some water, and compressed air. While we have the same system using hot oil. In this case, of course, typically you need a boiler if you don't have spare capacity. So you need a boiler to have the hot oil. Again, some electricity, nitrogen, water, and compressed air. So both versions are available. And for us, it depends mainly on how much it costs electric energy or thermal oil to be produced country to country, because we have different situations. Talking about the full electric version, we can say that on site we are really what we call zero impact. So we not having the need to use a boiler. We really can say that we have zero CO2 emission on site. Another advantage of the electrical version is that we can do a cold startup. You can understand, of course, it's not the case of Southeast Asia, but in cold countries where in winter time the temperature is extremely low, to heat up the oil we need maybe to wait the oil to go to the temperature, while for the electricity is not the case. We don't need to have methane gas or propane gas on site. We don't need to install hot oil piping, and with electricity we don't have any problem for thermal insulation, so we don't have the issue with the heat dissipation like we have with the hot oil. But again, it depends on country to country on how much is the cost of the energy. This slide shows you an example of a company using all the possible technology for the flexible packaging, like rotogravure machines, laminating lines, flexo printing machines. And in this slide, you can see the very high flexibility of the solvent recovery, how is designed by DEC today. Because I can imagine in my plant, for several reasons, to dedicate, for example, one skid. You remember the skid system that we have seen before? For example, I can imagine to dedicate one skid to collect the exhaust air from the rotogravure machine. Or maybe I can decide to start to use one skid and connect only the laminating lines, or even to dedicate another skid to the flexo printing machines. But if you look at the bottom part of the slide, I can even decide to collect the air coming from all the converting lines together, and to install maybe a multiple skid system, which is would be my entire solvent recovery system, and to collect all together all the solvents, and then through distillation system to separate acetates, alcohol, and so on. So this will you better understand the high degree of flexibility of such a system. Not maybe anymore like in the past that we were thinking about a big solvent recovery plant. Today, with this modular system, we are able to do all kind of configurations. Again, as I said before, we recently introduced the 4th generation of a smart modular system dedicated to the flexo printing lines. In this case, again, the concept of closed loop comes again. I just need to purchase the inks from the market and recovering the solvents that I can directly reuse in our production for infinite times. I close the loop. So this is the example dedicated for the flexo printing, which is the latest development by DEC. In this slide, you see an example. If we have time later, I will show you a virtual tour in this plant. But let's start with this slide. For example, this is a typical example of what the flexibility and what we are able to do today with the smart modular system. So this customer based in Italy decided to install the first skid that you see in yellow on the left and connect rotogravure and lamination and recover the solvent. This was installed 1.5 years ago. As a second step, he decided to connect also flexo, and he installed a second skid. And you see that they bring to the main exhaust duct the air coming from the flexo line to the right skid. So this is one example. So the customer decided to split in two different skids the exhausted air coming from rotogravure lamination and on the right side to the flexo line. This is just one of the examples. And you see that the footprint is not that big. We are talking about not a big installation. The skid that you see over there is more or less 14-meter length and 3-meter width. In the middle, they install a small shelter containing the chiller. And there in front, you see another small skid with the distillation column to recover ethyl acetate from the solvents. The family the family of solvent recovery shown on the previous slide is exactly the one that is on this slide. You see the footprint is very small. This series that we call 2306 has a capacity of up to 30,000 cubic meter per hour when we install 6 adsorbers on the top. The slide shows 5. So with the 5 adsorbers, the capacity would be 25,000 cubic meter per hour. But again, being modular system, we can have another family of systems with the same concept, but with the little bigger diameter of the adsorbers. For example, the one shown on the slide with the 6 adsorbers on the top has a capacity of 50,000 cubic meter per hour, but we have the possibility to expand this system up to 80,000 cubic meter per hour or even more. For example, the one in the slide that we see now is capable to cover a capacity of up to 90,000 cubic meter per hour. So we really are flexible, and with increasing the number of adsorbers with the activated carbon inside and increasing the number of skids, we are able to cover any capacity of the plant. You see, this is a complete different layout that we call U-shape, and the one shown on the slide with 8 adsorbers on 2 sides has a capacity of up to 70,000 cubic meter per hour. But again, it's just an example because we are able to combine different number of adsorbers, and with additional skids you can increase more and more. Again, this new generation of solvent recovery was designed to be installed on a very simple concrete platform. In the area where we have the skid, we need only 2 tons per square meter, and basically this is the weight that you have to design your slab, while for the distillation sometimes could be a little bit higher, 2-3 tons per square meter, but we are talking about very low weight in general. The system can be installed on the ground, but also on a platform when there is no space on the ground. It can be installed on the roof. So there are several possibilities for the installation. Why we say plug and recover? As I mentioned before, the core skid is fully pre-assembled, pre-cabled, and already coming with the thermal insulation. You see the blue parts are the parts already thermal insulated by our production people. So this is how the customer receive the skid. So you can easily understand how short is the installation time, because when I receive a pre-assembled skid which already contain all the parts for the process, you see how easy is then to place on the installation site, and then to just put on top the adsorbers. These are installation going on in these days. For example, one is in Brazil, Amcor Londrina, but we have several in Turkey, Egypt, everywhere in Europe and around the world. You see that after also on the left, you see a slide showing that also the distillation skid is coming pre-assembled and with pre-thermal insulation. They just put on top the adsorbers on top of the skid and to do the final connection. But let's talk now a little bit about the return on investment or the saving of our system. This slide is a comparison between RTO and solvent recovery unit. The big advantage of the solvent recovery unit today is that since the first day when we start up the system, you start to save money. So you start to make money through the solvent recovery, because you will not buy any more solvents from the market, because you reuse the solvent that you recover from your own machines. So since the first day, the blue line is going up, recovering money, saving money, and typically we do many exercises every day because we have many quotation. many new projects every day. And typically, when we simulate the ROI for a customer, the ROI is less than 2 years. With the price of today solvents, with the energy that we are able to save, typically the return on investment today is less than 2 years. While using an RTO, you start losing money every day because you need to continue to buy your solvents. You burn and you spend energy to burn your money, to burn your solvents. So it's a losing money technology, RTO. And the red line, of course, is going down and down and down. And every year I spend millions of dollars to buy solvents for dilution, while on the other side, with the solvent recovery, I don't spend anymore this money to buy solvents for dilution. This is just an example. Let's consider a company where this company use in production 1,500 tons per year of solvents. Okay. If we can say that today the price of, for example, ethyl acetate can change country to country, period to period, from 1.5 up to $2 or even more per kilogram. Since the operating cost of a solvent recovery unit to recover 1 kilogram of ethyl acetate is approximately $0.15 per kilogram, it means that for this company using 1,500 tons per year, it's easy to calculate that every year this company could save more than $2 million per year, depending on, of course, how much is the price of 1 kilogram of solvent. But I just gave you some example. In this slide, I give you other example. So with the smaller company using only 1,000 tons per year, or a bigger company using 2,000 tons of solvents per year. So you see that in any case, the saving, the yearly saving is a big amount, is an important amount, even in the worst condition, where maybe the price of the ethyl acetate is not $2, but maybe is 1.5. But even in that case, according then to the consumption of the solvents, you can easily deducting the operating cost of the solvent recovery per each kilogram, you can easily calculate the yearly saving. So, and then the big question, what about you? Because the time is flying, and with the solvent recovery system, we can recover the solvent, but not the time. So it's time probably to invest in the solvent recovery. Again, I would like to thank very much MPMA and Rickerman for hosting us. If I have time, I ask to the organizer, I would like to show you at least a portion of a short video. So nobody complains, so I go ahead. This is a virtual tour of the system that we have seen before. So the one that I show you consisting of 2 skids. So we go around the system. You see that is very compact. On top, you have the adsorbers with the activated carbon. Below, you have the entire process of the solvent recovery. We arrive now to the let's say to the beginning of the process. You see on the right side, on the lower part, the filtering and conditioning room, where the air coming from your converting lines entering the filtering and conditioning room. So we filter the air and we typically cool down the air to 35 degrees, and then we send the air to the absorbers on the top, which will capture the solvents. We turn around now because I want to show you other things. You see on the top the main duct coming from the, in this case, coming from the flexo line, because you remember this skid on this side is dedicated to the flexo printing lines. So here below we have an electrical cabinet with for the power supply. On the top, you see now there is the stack to exhaust the clean air after filtering the air in the absorbers with the activated carbon. We can send the clean air to the atmosphere from this duct. Again, on your left, you see the filtering and conditioning room where the air will be filtered and cooled down. And then we find the main ventilator, this blue one, blowing the air to the absorbers to have the first process of absorption. The one that you can see over there is the fan that we use for the regeneration. So we blow hot nitrogen to the absorbers to regenerate one absorber. We have the heat exchanger and solvent condensation. In the middle between the two skids, the customer installed a small shelter containing the chiller and maybe the compressed air, I don't remember. So this one is the skid for the flexo printing. On the left, we have the skid for the rotogravure and lamination. This is the solvent tank to collect the recovered solvents. On the left, we have the distillation skid, pre-assembled and also thermal insulated. We have the distillation column. Yeah. Okay, then I think I can stop because again, we would see the same. Okay, this is the skid for the roto lamination, but again, this skid is basically identical to the previous one, so we would see exactly the same concept like before. So I think we can skip this. We can stop this presentation. Okay. Thank you very much. We are available for, I think, questions, if any.
Vincent, are you here? Yeah, Vincent. Okay.
Thank you, Mr. Fabric.
Mm.
So now we are going to the Q&A session.
Michael, Michael is here. Okay, Michael is here. Okay, come. Let's continue.
Okay. So we just see the checkbox. Now we have 3 questions for Michael and Mr. Fabric to answer first. So the question number 1, dear Mr. Michael and Mr. Fabric, for both liquid and VCO recycling technologies, the solvent can be recycled for infinite number the time, or is there a limit of number of time that this solvent can be recycled?
Then I start answering. No, there's no limit. We can always treat that solvent in a cycle using the solvent recovery in the distillation unit and returning back to the next washing process. And we do it continuously without any limit.
Yeah, same for me. I think indirectly, I already answered through my presentation, because I said a few times that in our technology, you recover the solvent for infinite times. So there is no limitation. It's a closed loop system. So again, being a closed loop, we recycle the solvent, we recover the solvent for infinite time. When we recover the liquid solvents, we use as dilutant again for our inks, varnish, lacquer, adhesives, and then we print, we laminate, we exhaust the air, we collect this air full of solvents, we condensate, and we reuse again as dilutant. So infinite times.
Okay, thank you. So for question number 2, for Mr. Fabric, what is the basic difference between the standard system of solvent recovery and the smart modular system?
I would say the standard, or say the conventional system was based on a concept which was let's say not so modular like it is today. Again, also in the past it was possible to think about expansion for the future, but it was less forgiving, let's say, or less flexible. In the past, it was not possible to think, for example, to dedicate one skid to, let's say, rotogravure lamination, and, for example, one skid to the flexo, like the video that we have seen before. In the past, typically there was the main concept was to have a big solvent recovery plant and collect all together. Today, the customer can easily, for example, decide to start to connect all the lamination lines. It would be even easier to do so, because you can recover. You are in a monosolvent configuration. Typically, in Southeast Asia, I would say the easiest way to proceed could be, I start to connect all the laminating lines, which are using monosolvent, which is ethyl acetate. I connect the laminating line to the solvent recovery, and then I could think in the future to connect to the same skid also the other lines, or to dedicate an additional skid to collect typically in that case a multi-solvent configuration, which would need typically a multi-distillation system. But the SMS, which is the smart modular system, which is the state of the art today, again can grow, can be expanded by adding on the top one or more adsorbers, or by increasing the number of skids. So in the process of solvent recovery, there is no difference between the traditional system to the smart modular system. So the process to recover the solvent is always the same, developed by DEC more than 30 years ago. But the engineering, the new concept is more on the energy saving, the compact size, the fact that when the system is coming pre-assembled from our workshop, the installation, you remember, will be plug and recover. So easy to transport, easy to install, very quick to start up. This is because it's pre-assembled and it's almost in several skid. You remember, there is not only the core skid for the solvent recovery, but also the skid for the distillation. We have the skid for the dehydration system, which I didn't mention too much in the presentation because otherwise it would be too long. But we have, so the system today is consists of few skid-mounted system, which is the solvent recovery, distillation, dehydration system, and this is the big advantage. So transportation, installation, startup, and the fact that doing so, we were able also to reduce the capex, because you can start, again, sorry to repeat, you can start with a small system, you recover your money easily, immediately, and then you invest the fresh money in the expansion, in the additional skid, if you want. This is the big advantage.
Okay, thank you. So now we go for question 3 for Mr. Fabri. Can the smart modular system be extended in line with the additional capacity of the commoding machinery?
Yes, yes. If I understand well, they ask, can the smart modular system can be expanded if an additional printing line or laminating line is installed in the plant? So I mean, if they expand the capacity, the needs to the exhaust capacity of the plant, if the system can be expanded, the answer is of course, yes, as we said before. For example, a company having 3 laminating lines and 3 rotogravure machine, in the future, they will install an additional laminating line, an additional rotogravure machine, according to the capacity of the skid. The skid can be extended in length, so by installing additional adsorbers on the top. You have to imagine that in the standard series, which is the one that we call 2906, 2909, each adsorber would increase the capacity of the system of 10,000 cubic meter per hour. So if, for example, I install a modern rotogravure machine today, a modern rotogravure machine equipped with the LEL system typically has a capacity of 25,000, 30,000 cubic meter per hour, while a new laminating line, a combi line, typically has air volume of from 10 to 12,000 cubic meter per hour. So it's easy to understand what I have to do with the solvent recovery. So if I install a new rotogravium line, probably I have to install 2 or 3 additional adsorbers, or I can start with an additional skid side to the existing one and increase the capacity installing an additional skid. I hope I answered the question.
Okay, thank you. And now question number 4. What is the typical recoverable solvent concentration property? So this question, I would like to check with Mr. Michael or Mr. Freiberg, who can answer.
I will start. I think we have to separate with question 2 questions. With our systems, we recover mix of washing solvents. It's a mix of ethyl acetate, ethanol, some other alcohols, and so on. We put in the mix and we get a mix of distillated solvent back. So purity means it's clean. This is 100% clean. There are no solids, no pigments from the inks, any other things left in the distillate. But we don't separate the different types of solvent. So maybe you remember the presentation of Fabrizio. He mentioned about monosolvent line and multi-solvent lines. At the multi-solvent lines, you saw the column. This column, I'm sure Fabrizio will agree, is to separate the different types of solvent. We don't separate. So we just put a mix of solvent in the unit, we get a mix back, which is fine for the cleaning purposes, but not for diluting the inks.
Yeah, exactly. I agree with what you say. For DEC, basically we don't have a limitation in the concentration or in the type of solvents to be recovered. Of course, there are some blacklisted but very rarely used solvents, but of course we always discuss these with the customer, and we find always a solution for this. In our concept, we size the solvent recovery system according mainly to 2 big parameters. So when we discuss with the customer, typically what we ask the number of machines working in the plant. So the number of machines that potentially they can connect to the solvent recovery, including, I want to add, including many times the customer, they want to connect to the solvent recovery of DEC also the washing machines. Why? Because in the washing machines there are using solvents, and the exhaust of the solvent of the washing machine can be sent to the solvent recovery. I'm talking about the fumes. So I don't want to take the job of Michael, because Michael is working liquid to liquid. I want to take my job, which is from the fumes, so from the air with the solvents, and recover to liquid solvents. So what we ask to the customer, how many lines you have and which kind of lines you have in your plant, and then how much solvents you buy for dilution every year, and how much inks, adhesives, or varnish or lacquer you buy every year for your production. And inside these adhesives or inks, how much is the solvent already inside the adhesives or the inks? Because with this information, we calculate on one side the air volume that we have to manage. Okay, according to the number of machines, according to the size of the machines, we have an amount of air exhausted, 80,000, 150,000 cubic meter per hour, 50,000 cubic meter per hour, whatever it is. And this gives us the volume of exhausted air coming to the inlet of the solvent recovery system. On the other side, if knowing the amount of solvent that is coming, that is put in production, so it's coming to the solvent recovery, we are able to size the number of adsorbers and the number of skids. You have seen one example in the one that I show you, the virtual tour. This customer has a limited number of machines. The system is the small series that we call 23, the series 23. And the total capacity of that installation is 50,000 cubic meter per hour. So 25,000 each skid. But I show you other slides where one skid can handle a capacity of up to 90,000 cubic meter per hour. So, I mean, we are basically, we have no limits in the air capacity and no limits in the amount of solvents that we can recover. But it's true that based on the air volumes and based on the solvent concentration, so the amount, the kilogram per hour of solvents coming, we have to decide how many adsorbers and how many skid we have to install.
Vincent?
Yes.
Vincent, I think, thank you, Mr. Fabri, for answering the question. Thank you, Michael, also for answering the questions. I think, Vincent, we shall end the Q&A at this point. There's no more questions in the chat box.
Okay.
And we shall wrap up the session. Punita, can you put on the next slide, please? Okay, at this point now, we'd like to invite our sponsor from Recommend, Mr. Tun, to say a few words. Mr. Tun, are you there?
Yes, hello everybody.
Yeah.
Yep. Okay, I'm Tun from Recommend Malaysia. On behalf of the Recommend, we'd like to thank MPMA to organize this event. Also to all the speakers and moderator for your great presentation, especially to all the guests who taken up your time to attend today's webinars. I think you have clearly explained by all the speakers, Mr. Fabri and Michael as well. Today, this solvent recycling technology not only bring economic benefits to the company, also it enables us to protect the environment together. So if you have further interest to find out more about this liquid solvent recycling and also VOC solvent recycling, kindly contact us. I'm Tun from Malaysia. You can contact me if you are from Malaysia. If you are from this region, either you're from Indonesia, Thailand, Vietnam, or Philippines, please contact Recommend of your local Recommend office. All right. Yeah. That's all for myself. And thank you very much. Thank you very much for your time. And Recommend is always support you. All right. To the end. Thank you. Thank you. All right.
Okay, thank you, Mr. Tun. Thank you so much. Okay,
right.
Vincent, maybe you can do the wrap up now, Vincent.
Oh, okay. So in closing, I would like to say that to run a successful business in our new normal economy climate, where nothing is certain, one must implement practice that foster overall cost reduction. This is where on-site solvent recycler truly shine. In today's economic climate, the writing is on the wall. What is good for the health of the planet is good for business. Governments around the world are continually rolling out an increasing carbon tax in an effort to reduce our environmental impact. What is clear is that environmentally concern and responsible practice in industry are both rewarded and financially prescient. Taking the step now to reduce one carbon footprint will undoubtedly contribute to the success that business see in the future. Speaking of carbon footprint management, MPMA is running a program to help company understand their carbon footprint. I request company to find out more about this by contacting Ms. Crystal of MPMA Secretariat. On this note, I wish sincerely thanks our two speakers, Mr. Michael and Mr. Fabri, for the information shared with us today. I also wish to thank Recommends for sponsoring today's event. On this note, I wish everybody a good day. Thank you.
Okay, Mr. Tun, can you put back your video on, please, so we can take a group photograph? Punita, are you ready?
All right.
Okay, come, everybody smile. Can we have all the panelists smiling so we can take a group photograph? Okay. Punita, one, ready, yeah? 1, 2, 3. You want to take one more? It's okay? All good, already, yeah? Okay. On this note, I wish to thank once again Mr. Fabri and Mr. Michael for your precious time and for sharing with us all the information, and to Vincent, our moderator, for today's session, and also to Recommend and Mr. Tun for sponsoring today's event. And with that, we wish everybody a good day. Thank you. Bye-bye.
Yeah, thank
Thank
you.
you. Bye-bye.
Okay, thank you.
Thank you.
Thank you. Okay, bye-bye.
Bye-bye.
Bye-bye. Bye.